And again, these are questions we've done before in degrees, and now we're just switching them to radians. So as far as our thinking goes, we just change our mode on our calculator, but we still do everything the same in the same idea. Negative 4 comma 3. Negative 4 comma 3. That's that point right there, is a terminal point on the terminal arm of an angle theta in standard position. So here's our angle theta in standard position. Here's our point negative 4 comma 3. We are supposed to determine all the possible values of theta. So when solving for an angle, we're always going to have our reference angle. So if I draw it back to the nearest x-axis, this is my reference angle. And if I have that reference angle drawn, what do I know? I know this length is 4, this length is 3. So if I wanted to calculate my reference angle, so Katoa, would I use sine, cos, or tan? Tan. So I can write tan of my reference angle is 4 over 3. Does it make sense that tan of my reference angle is 4 over 3, but tan of theta would be negative 4 over 3? For idea's sake? Because if I'm actually talking about the triangle, a triangle has all positive values. Whenever you're figuring out your reference angle, you're going to use all positive values. But according to the cast rule, in quadrant 2, tan would be negative. Yes, Terry? Yeah, it would be 3 over 4. There we go. So no, it didn't make sense that it was negative in one and positive in the other because I had the numbers wrong. But it'll be negative 3 over 4 here and 3 over 4 there. Opposite over adjacent. Wonderful. And so if you wanted to calculate what your reference angle was, you could go, my reference angle is going to be, I go to my calculator, I go tan inverse of 3 over 4. Now when you got your reference angle using degrees, your reference angle is always between 0 and 90 degrees. And now when I go tan inverse of 3 divided by 4, it's a little bit harder to tell that that's the right angle, 0.64. But that angle is between 0 and 90 degrees. If you did this in degrees, okay, so sometimes it's not bad. I'm going to just change my mode to degrees. And say, oh, I got 37 degrees. How would you find out what theta is if you had to do this in degrees? You'd take 180 minus your reference angle. Can see that from the picture that that makes sense? So you would do 180 minus 37 degrees. So you're going to have to often ask yourself at the beginning, how do I do this in degrees? And now, can I do that same idea in radians? So to find theta, I can't do 180 minus the reference angle because that's in degrees. To find theta, I'm going to do pi, because pi radians is equal to 180 degrees, minus my reference angle. Go back to my calculator. Pi minus my reference angle. .49, it says round to the nearest tenth. And we got theta is equal to 2.5 radians. So again, we often think in degrees at the beginning to get an idea of how I would have solved this same question in degrees, and then we apply to radians. So one of the things you really have to get good at is you have to be really, really strong and comfortable with solving all your trig questions in degrees so that you can make the transition into radians.